What is going on? What is up, YouTube? This is Mr. King coming at you live with the next video. So today, Monday, May the 4th, be with you, is all about just answers. It's going to be another catch-up day. That's what the majority of people wanted for their last survey. So all I'm asking for today is you watch this answers video. So we're going to start with the Punnett square practice. This one, I saw a lot of wrong answers, and the hardest part was the chance. So what I noticed is a lot of people were having some very random numbers in the chance, and everything you do, all the percentages, it should just be out of 4. So it could be 1 out of 4, 0 out of 4, 2 out of 4, or 3 out of 4, or 4 out of 4. So it should be 0, 25, 50, 75, or 100%. Those are all the possibilities for chance. So we're going to start the first one. White wings are dominant to yellow wings. If a W and a small w butterfly mate, what are the possible gene types and phenotypes? So the first one did the Punnett square for you. And then as you can see, whichever one with the capital letter, that one is going to have white wings because it's dominant. So I'll give you all the possible genotypes. So out of the 4 kids, 0 out of 4 or 0%, 0% have 2 capital W's, 50% or 2 out of 4 or 1/2 have white wings with this genotype, and then the other half have yellow wings. Okay, the phenotype. So those are just the 2 possibilities of what the butterfly is going to look like. So it's going to be yellow and white wings. And then the chance, 1 out of 2, because that's half the kids. Okay, moving on. Dogs. Deafness is a recessive gene. 2 dogs carry the gene for deafness but have normal hearing. So since they carry the gene, they're going to be heterozygous because they both have the disease allele, but both of them have normal hearing. So they're going to be heterozygous. 2 heterozygous dogs mate. They both carried this little d for deafness allele. And then we do the Punnett square, bring these across, these ones down. Capitals always go first. Boom. Okay. Then I'm asking how many of each genotype will result? So there's 1 out of 4 of the 2 capital D's, 2 out of 4 here, and then 1 out of 4. And then I'm asking, how many dogs, this is important because humans deal with the same thing. What's the chance that your child is going to have normal hearing or be deaf? Hearing, sensitive. Okay, so 3 out of these 4 kids, 3 out of these 4 puppies will have that capital D, so they'll have normal hearing. And then 1/4 will have no capital letters, so that one will be deaf. 1 out of 4, or 25%. Okay, that's the next one. Now on to guinea pigs. Guinea pigs, if a short-haired 2 capital letters guinea pig is crossed with a long-haired one, like this clip art, what are the possible gene types, phenotypes of the offspring? So 2 capital letters, bam, bam, and this one, and then it looks like, you guessed it, all of their offspring are going to be heterozygous. So 0, 100%, 4 of 4, and then 0. Okay, 0 of 4. Phenotype, short-haired. Okay, everybody. On here, since no 2 double S's. Okay, next one, tongue curling. Okay, that one is a dominant trait. So whoever has a capital T will be able to curl their tongue. And we have 2 heterozygous individuals. Bam, bam. Here we are. Okay, we do the cross. Big T's come across, these ones drop down. Okay, and then this one's very similar to the deafness one. So we have 1 kid with 2 capital T's, 2 kids with heterozygous, and then 1 will not be able to roll their tongue. So this will be 1 out of 4, 2 out of 4, 1 out of 4, and then can roll It's funny. It can't roll. That this child, 1 out of 4 chance. They can't roll a ton like that. They'll just do nothing. Okay. Next one. This quiz was confusing, I know, but it's very important because it explains how these two girls are twins. It's crazy. It's pretty rare, but it is possible. So we're going to go over the quiz, how it works. So I want you to figure out what traits based on these alleles and chromosomes do the parents have. And then you're supposed to use this chart. So if you ever have a capital letter, you're going to get that dominant trait. If you don't have a dominant letter, like the dad, you're going to get the recessive one. So curly hair is dominant, so the dad will have straight hair because he doesn't have a capital letter. Skin color, this mom is half black, half white, and it looks like she's going to have darker skin because she has that capital D, and this one has light skin. And then hair color, red is pretty rare, so it's recessive, and then dominant, it's brown. So the mom has brown hair, so does the dad. Okay, cool. Now, this was the tricky part. Lucy. Lucy has light skin and red and wavy hair. So this was where you have to work backwards. We know what she has. Now you have to figure out which of the letters did she get from her parents. So we know Lucy has light skin and she has wavy/curly hair. So if she has curly hair and your parent, the mom can only give her capital H and the dad can only give her his lowercase h. So that's what we know to do here. And then for the skin color, so Lucy is light-skinned, so her mom cannot give this capital D. She has to give this one because Lucy ended up with light skin. So we know she has to have 2 little d's. So her mom and her dad both gave that lowercase d. Also note before I edited this out, but I was too late. They put the letters right here just to show what are the 2 possibilities. It didn't mean that's what you had to give. Okay, hair color. We know she has red hair color, so that's going to be 2 lowercase h's. So both parents need to give the 2 lowercase r's. Okay. And then explain how it's possible using these words. So Lucy is able to have light skin because her mom carries an allele for light skin, which is recessive, and she gives her light-skinned allele to Lucy, and the dad only has light skin. So we must give that allele. Okay, that was, your English teacher would have given that a D because it's correct, but it has terrible grammar because it's a run-on sentence. That's okay with me. I don't care. We didn't use genotype and phenotype. Lucy has a heterozygous genotype for hair texture. So she has a dominant and recessive allele, and her phenotype is the dominant trait for curly/wavy hair. Okay, cool. So that was how you do Lucy. And then you now how to do Lucy. If you want to revise your quiz, you can. And this is how I want you to do Maria yourself. And I also said a Punnett square may help. So you could draw a Punnett square. So you do insert, table, and then you could actually show me how it's possible. You could have the light skin genes, moms, which was, here are the mom's light skin genes, and then here are the dads. And then you could show that half of the mom's kids will have darker skin, and then half will have lighter skin. That was what I meant by a Punnett square could help. That was a little tricky. Not many people actually thought of drawing their own and making one. That was a little more difficult. Okay, moving on to the next one. This one was very confusing. This trihybrid skin cross, this is the last one we're going to do for today. We are moving away from genetics and into protein synthesis. So I want to go through all the genetic stuff before we fully move on. Okay, based on the reading, what you know about genetics are darker skins or lighter skins, dominant or recessive. It's darker skin. If you remember from the quiz, darker skin is dominant. Okay. What alleles that represent the lightest color? So how you do this one, you look through the table. This very corner has the lightest skin, and that looks like it has mostly lowercase. So it's the lowercase letters. Okay, moving on. The Punnett square has various combinations of alleles. What are 3 possible phenotypes that are predicted from the cross between 2 medium skin toned individuals? So what I noticed a lot of people said, they actually put the letters. Phenotypes. So you gave me genotypes like A, blah, blah, blah. Yeah, that's all genotypes. Phenotypes is what they look like. So you could have said very dark skin, very light skin, and tan skin. Those would have all been 3 possible phenotypes. Okay, and then I had this one here. What is the chance? So out of 64 boxes, so that was my hint. How many of the children have the darkest of dark skin? That's 1. So the chance is 1 out of 64. And then that's the same for the light skin one, because there's only 1 kid with that super light skin. So that's going to be 1 out of 4. Actually, I would have taken 2 out of 64 because these kids, they have very close skin color. So you could have said 1, or I would have taken 2 because it looks like both of them have around the same shade of light skin. Which phenotype is most likely? So how you do that, you look which of these boxes is the most common, and it's looking like this tan one. So you could say tan or like light orange, and then you would count how many boxes have that same shade. Orange, tan skin, and that was about like 24 to 64. Okay, based on this Punnett square, it's predicting a polygenic trait. Polygenic means there's a lot of chromosomes and genes involved. Is that simple or complex? Explain your answer. I would say complex. When you have a lot of alleles to keep track of, it makes predicting color very complicated. Okay, last one. After interacting with the Punnett square above, answer the guiding question from this unit. How is it possible 2 siblings have very different traits such as skin color? So whatever you say here, that was supposed to be a sneak peek for this CER. This is where you're actually explaining how these 2 twins look way different. And a hint, this quiz will also help you. This quiz will help because you're essentially explaining how the 2 girls look way different using alleles and not necessarily quotes. So you can use this as evidence too. Okay, thank you for staying with me the whole time. That's all for today. I just wanted you to watch this video and revise your work and catch up. As always, I like to finish the videos with a fun fact. My fun fact for today is if a goldfish is left in darkness for a very long time, then it'll eventually lose its gold color and turn white. I saw that on the Snapple website because they always give a fun fact at the other side of their caps. Okay, I will see you next time. Bye, guys.